magnetic moment. So the slope will be the magnetic moment divided by h. And with that you can calculate some quantities like the G factor that I hope you'll do later on. Alright, so now let's try to find the signal on the oscilloscope. Right now I don't see anything, so I see that this is stop. Let me run. And it seems, let me change here. Okay, so someone was measuring before with another configuration. Let me do an auto set, because then I will reset everything. Okay, I can see that the persistence is very high here, so I can change the persistence. So I click here, display persistence, let me clear, let me change it to very fast, 60 milliseconds. Okay, and right now I don't see anything there. Let me change the time division. See anything either? Let me change the voltage division. Okay, I see something here, but I cannot fix it to the center of the display. And with that I can solve using the trigger function, because the trigger tells the oscilloscope exactly when it starts to measure. And and we are oscillating the weak field at 60 Hertz, and we should match these at 60 Hertz as well. So I'll use the trigger, and the menu will be channel 1, and I can change the level of the trigger right here. And now I have a stable signal. So now I can change the time division here, and I can get a nice signal. So let me center this to the screen. I can also change the position here, and I can measure from here to here. This is very noisy, so I can do some integration and do some averaging here. So I can go to measure, and somewhere I can not here, acquire probably, mode, and then I can select average. Let me select a smaller number, 16. I can also change the persistence, display persistence. So all right, now I can measure from this peak, this valley to this peak. So I can select cursors, and I can move the horizontal cursor here to match this peak here, and I can move the second cursor. So if I click here, I can move the second cursor there, and there I can measure T2, the delta T, which was 227 microseconds. So that was the dephasing time of the system. All right, so this is the digital oscilloscope. We have the analog one. A nice thing about the analog one, if you've never seen it, that's an electron beam. So I have right here in my hand a magnet, a strong magnet. So we'll do some tests. Don't do that at home, because if this is an electron beam, I can deflect. Due to the Lorentz force, I can deflect this beam. So if I bring this closer to the screen, I may be able to deflect this beam, as you see. So Yeah, and there is a phosphorescent screen there. So then when the electrons hit the screen, it emits light. All right, so I hope you have, I have reviewed this, and I hope you have understood this